Hi, let's take a look at an example of calculating how much mass is needed to change the velocity of a rocket. So, say we have a spacecraft that's traveling at an initial velocity of 400 meters per second, and it has engines where the relative exhaust velocity from the direction of forward travel is minus 1,000 meters per second. And we need to increase the velocity by 2.2 meters per second. How much mass is our rocket going to lose in order to accomplish this change in velocity? Well, the rocket equation that we worked out says the final velocity of our rocket is the initial velocity of our rocket minus the relative velocity of the exhaust times the natural log of the initial mass divided by the final mass. Well, the initial mass is going to be larger than the final mass, which makes this number larger than 1 inside the log, which means our log is going to be a positive number in this case. So if our relative velocity is negative, our rocket ends up going faster. Now, if we want to solve for the mass, though, really we want to take a look at removing this initial velocity from each side, and v final minus v initial is just the change in velocity that we're seeking. That would have to be equal to minus the relative velocity times the natural log of the initial mass over the final mass. So to solve for this ratio inside the log, we divide both sides by minus the relative velocity, and that would say that the log of the initial mass over the final mass is going to be the change in velocity divided by minus the relative velocity, and to undo a natural log, we use Euler's number. We'll raise both sides, we'll raise Euler's number to the power defined by both sides, so the log gets scrubbed away, and the initial mass divided by the final mass is going to be e to the negative our change in velocity divided by our relative velocity. And our initial mass would be our final mass times e to the minus change in velocity over relative velocity, or more commonly to think about it, since our mass is going down, our final mass would be our initial mass times e to the plus change in velocity divided by the relative velocity. So filling in the details, we don't know m initial, but relative to m initial, the final mass would be m initial times e to the negative 2.2 meters per second divided by 1,000 meters per second, and e to the negative 0.0022 is 0.9978 times the initial mass. So the object is going to lose 0.22% of its initial mass in order to make that 2.2 meter per second change in velocity happen. Thanks for watching.